Good morning, everyone. Miss Butler here. I'm going to help you get ready for your KSP of calcium hydroxide lab. All right, so you're going to do this lab in your lab notebook. Make sure you add it to your table of contents and you're using pen. Any sections that are bolded and underlined need to be labeled in your lab. Anything that is not bolded and underlined, you're expected to read through and do, but it does not need to be like a section in your lab notebook. So we have our purpose. We're going to try to determine the KSP of calcium hydroxide by doing a titration. You can read through this background information. It will help you with some of the pre-lab questions and some of the calculations. There is a short YouTube video that you're going to watch about hard water that, again, will help you with one of your pre-lab questions. So more of the background information. Again, the main idea here is if I can calculate the molar solubility, or X, I will know the concentration of OH and of calcium at equilibrium, which is saturation. And if I know those concentrations, then I can plug into my KSP expression and solve for KSP. I should see the materials in your lab notebook. So that should be a section. And then for your pre-lab, so you're going to write a 3-sentence summary for number 1. About hard water. You're going to watch a second video about the techniques for setting up a titration. It does say I need to see these steps in your procedure, so you don't actually need to do anything right here for pre-lab question number 2, but I should see it reflected in your procedure that you're adding in these steps about how to rinse and set up your burette. And then there's a question about writing the reaction and the KSP expression for calcium hydroxide. All right, so you'll have a procedure. This needs to be done before coming to class. So you're going to draw pictures. So you can have labels for the amounts and the sizes of things, but it should be detailed pictures. And remember, anytime you measure something, I should see what you're measuring it in reflected in your procedure through the drawings. And anytime you record anything in your data table, there should be a note or a sketch, maybe a pencil to show me that you know to record that measurement or that information. Okay, so measure the temperature of the stock solution. So you will record the temperature of the calcium hydroxide each trial, mostly to make sure that it's consistent. We know temperature can impact KSP, so we're just making sure there's no drastic changes from start to finish. And you'll record that in your data table using the proper sig figs. Step 2, set up a funnel, filter paper, and clean beaker and filter about 100 milliliters of the saturated solution. So before we can actually do the titration, like you saw in the video, I have a solution that is essentially oversaturated. So you'll see that there's going to be a big beaker or a flask that says CaOH2, and it's going to have some cloudiness or some flakes in there because we can't have any solid in our burette and we really just care about the perfectly saturated. I'm going to need to filter this. So you will need about 100 milliliters. So you'll take about 100 milliliters from the main container in the classroom, and then we're going to go and we are going to, so take it in any size beaker, that's fine. And then we are going to do a filtration to filter out all of the solid. So I will show you kind of some tips on how to do that. All right, so you're ready to filter. You've obtained about 100 milliliters of the oversaturated calcium hydroxide in a beaker. And now we have our burette set up, but we can also use this ring stand for other things. So you have a clamp. If you open one of the screws wide enough, you can get it nice and wide so it just attaches, and then we tighten that screw so it stays on. You always want to be careful when you're doing multiple things. Just be careful of this burette tip. It's very gentle, or be gentle around it. It could break easily. And then on the other side of the clamp, I'm going to attach the ring. So you can see it's held on nice there, screwed in tight. All right, this is a clay triangle. We usually use it for heating up crucibles over a Bunsen burner, but for Legend High School, the clay triangle actually is the perfect size to hold our funnels. So I'm gonna put my clean beaker underneath, and then I'm ready to get my filter paper ready. So here's what our filter paper looks like. We want to make it into a funnel. The easiest way to do that is to fold it in half one more time, and then I call it the 3 versus 1. So there's actually 4 layers of paper. I'm gonna take 3 in my thumb and just 1 on this side and pop it into a triangle. So the best way to get the funnel shape is kind of tuck this side. And so I have 3, let's try that again. I have 3 layers of paper on this side and 1 here, but it'll still work nice. So I'm gonna stick that in here, and as you can see, it's kind of popping up. It's annoying. So the best way to fix that is get it a little wet. And that's not a big deal because calcium hydroxide, we're already gonna essentially add a little bit of water when we're filtering. So I have my oversaturated calcium hydroxide. I'm gonna slowly start to pour it in here. We wanna make sure not to overflow the funnel. So you have to do a little bit at a time. It'll start to drip down, and this will be your at equilibrium, perfectly saturated calcium hydroxide. Any leftover solid will be caught up here. You also wanna make sure you get everything, so we'll use this squirt bottle to kind of squirt and rinse a little bit if necessary, but here's the idea. We're collecting down here, right, as it's dripping. I know it says we need 100, but the burette only holds 50, and you're gonna do multiple trials. So I don't need you sitting here waiting for all 100 to filter, because we can filter while we do trial 1, while we do trial 2. You just need to wait until you get about 50 mils in your lower beaker, so you can fill up the burette and you can begin your first trial. And it can continue to filter for your second trial while you work on your first trial. So let's be efficient here. Once you get your 50 mils, you can start your first titration and continue to filter. Maybe one partner works on that while the first partner does the first titration. Okay, so that's getting your calcium hydroxide ready. Once it's down here, we're gonna put it in the beaker and we'll talk about that next, or in the burette. We'll talk about that next. All right, the next step, prepare a burette with the filtered calcium hydroxide. So no solids in the burette. This is the filtered, perfectly at equilibrium calcium hydroxide solution. This is where the video will come in handy. So you should have multiple steps here in your procedure for what's being described in number 3, because the video is gonna teach you how to rinse your burette, how to actually add the calcium hydroxide. So please watch that video, and I should see lots of steps, not just one single bullet point or one single drawing for number 3. Lots of detail. All right, in setting your burette up, you're gonna watch the video, so I'm not gonna re-go through that video, but I do wanna point out a couple of things. All of our burettes have these plastic pieces, and if you look, where's mine? Here we go. All right, when our piece is up and down, parallel with the burette, there is actually a little hole that allows the liquid to go down. So it is open. When we turn it sideways, it closes that hole, no liquid will come out. So you can even see there's the hole not open, and now it's lined up so we can drip out. Okay, I suggest, I know you're gonna be rinsing it and cleaning it out before you add the calcium hydroxide, but I suggest you each practice with water over the sink and seeing the speed that as you turn this, how fast it drips out. Because you will reach a point where you're gonna be adding 1 drop at a time. So you wanna get used to, is it a turn? Is it a quick drop, drop, drop? Is it a slow, like we're open, we're closed? Okay, I want each partner to practice just so you're used to how fast the burette goes. That will make your titration go better. When you fill the burette, you can painstakingly try to get it exactly at 0.00 as your starting point. That is fine. But you don't really need to, because we are going to record the initial volume, and then once it's done, once the endpoint is reached, we'll record the final volume to the correct number of sig figs so that we can then separate and figure out exactly how much we added. So you don't really need to fill it exactly to 0.00 as long as you record your exact starting location or starting value. All right. Number 4 on these procedure hints, measure 15 to 20 milliliters of HCl from the stock burette set up in the room into a clean Erlenmeyer flask, record precisely the amount of acid used, and then add 25 mils of distilled water and 1 or 2 drops of phenolphthalein to the solution. All right, so in the front of the classroom, there will be 4 burettes set up, each labeled with 0.050 molar HCl. And so these will probably be on the front table once I clean off my life, but you'll see them because they're labeled. And so here's the idea. You're going to bring your flask, make sure it's kind of clean from the last class, up to the HCl. You should also have your lab notebook with you because we're going to make measurements, and this is not something we just write, like put in our head. You are recording the correct measurements in your lab notebook as you go. So if we look, the hydrochloric acid in here right now has a certain reading, and I know it's kind of hard to get a good thing on the video, but if you notice, the burette actually counts backwards, 16, 17, 18, right? It starts at 0 and it ends at 50. That's not a huge deal because we care about the difference. So I'm actually going to read this guy just right where it's at. If I can actually get, there we go. So it looks like it is between 19 and 20. If I'm looking at the meniscus, maybe it's 19.89. Okay, so 19.89, make sure you have the correct number of digits. If there's markings every 0.1, you get an extra. So this is 20, so this was my 19.8, and it looked like the meniscus went almost to the 0.9. Okay, anyways, I am now going to add about 15 to 20. So if I'm at like almost 20 right now, I can go until we're at about 35. So somewhere down in here. And I just open this guy up. And we'll stop. So again, I'm not super concerned about exactly like getting exactly 15 or exactly 20, but I care about the reading to the correct sig fix. So looks like we're between 35 and 36. 35.1, 2, 3, 4. Might be 35.50 right on the money. I'm going to put that as my final volume in my lab notebook. And then I know the exact volume of hydrochloric because I have my starting and my ending on the burette. I just subtract them to figure out how much I exactly added. The next thing you're going to do is measure out 25 milliliters of water. So you should have a graduated cylinder. At your station, you should have a bottle of DI water. And so you can measure out your 25 mils, record exactly with sig figs, and you'll add it to your hydrochloric acid. So now we don't actually have 0.050 molar HCl. We have a new concentration because we've added some water to it as well. So that's part of your calculations. And finally, you're going to add 2 drops of the indicator to this guy. So in the video, he had a base at the bottom and an acid up top when he did his titration. You have the acid in the bottom. So when you add the indicator, you shouldn't notice anything crazy happening. It's not going to turn hot pink on you or anything like that, but it will change color when we need it to. So you'll add 1 to 2 drops of the phenolphthalein indicator. There will be small bottles around the room of that. And again, it doesn't take much. Just 1 or 2 drops is all you need. All right, so step 5, record initial colors of the calcium hydroxide, which is now in your burette, and the HCl, which is below the burette in the Erlenmeyer flask. And you're gonna do your titration. So when you do your titration, you can start to add and swirl, and you'll start to see some pink color swirl into the solution. The goal is that we get the color to stay. So when you notice that that pink color is staying for a little bit longer, like maybe you swirl it and it kind of stays pink, you should add drop by drop. So you add a drop, you swirl. You add a drop, you swirl. And the goal is that we get the lightest pink color ever, okay? It says repeat. So once you get that very, very light pink color, you will repeat until you have 3 trials. The goal is that we get 2 good trials. So if your first trial, maybe for example, you overshoot it and it turns hot, teenage girl bedroom pink, then we might toss that trial out and you're gonna try to get 2 more trials done. If your first trial is good and your second trial is good, you do not need to do a 3rd trial. We will need to be efficient so that maybe one partner is working on filtering, one partner is working on the titration, or even one partner is titrating the first trial and the other partner is getting the HCl ready for the second trial, things like that. So we just have to be efficient. I do want every partner to have a turn running the burette. So if you are the titrator for the first trial, maybe your partner tries it for the second trial. And then when you're done, you'll clean up, rinse it all with DI water, set your station up nice like it was for you when you arrived. All right, you've reached the end point. So you think that when you swirl, the color has stayed and you haven't overshot the titration, you think you're done, you're not gonna add any more, you've done slowly drop by drop. So a good way to check, I'm not actually done, but work with me here, people. Good way to check is if you have a white sheet of paper and hold up your flask to it. It should be such a pale, pale pink, like next to my screen here. It should be so pale that you can't really tell unless you have a white piece of paper behind it. And then maybe even holding up clear water next to it to just confirm that there is a light hue of pink. It needs to be that pink, baby's butt pink, versus a teenage girl, hot pink, bright city, right? So the goal is that we're going so slow at the end, drop by drop, that we can get the lightest shade of pink. That is our end point. That means we have reached for stoichiometry, the point where the moles of the calcium hydroxide and the moles of the HCl have reacted fully. They are both used up. They are both the limiting reactant. That's the end point. All right, before you come to class, you should have this data table set up and ready to go in your lab notebook. Notice some things. So we have the temperatures for each trial with correct sig figs, initial volume HCl, final volume HCl. So this is when you get it from the Burette. We record with the correct sig figs. That's why you need your lab notebook up at the Burette. And then the volume used, that's where you do your subtraction to figure out the difference. Okay, you're adding 25 mils. Make sure it's added to the correct sig figs. Same when we do the titration with the calcium hydroxide. You need to record the initial amount, and then the final, meaning the final or the volume that it says when you reach your pink, your light pink color. And then we can do subtraction to get that. Don't forget, you are observing what each chemical looks like before, and then you should always leave a note about your shade of pink, right? Because what if one is a light pink and one is a brighter pink, but maybe it's not that bright, right? But you should still leave a note about the shades of pink that you achieve. So if we have to throw out a trial, we would throw out the one that's the brightest pink. All right, I will not see the calculations or the conclusion before you come to class, but just so you know, when you turn in your lab notebook, these will both be sections in your lab notebook. A note on calculations: you should do these for each trial that you deem good. If the first trial is being thrown out, then don't worry about it. But you will do these for each trial, so I should see all of these for every trial, except for number 6, you will have for every trial, and then you're also going to get an average. So let's try that again. You will get an average for me from each trial. Okay, so you should not average every step. You should just average your final answers at the end. Okay, let's look through these calculations. We want to find the known HCl using M1V1. Well, we started with 0.05 molar, and you'll have somewhere between 15 and 20 mils. Put your exact amount. We're going to solve for M2, and then our volume 2 is when we add the 25 mils of deionized water, right? What is our new total volume? Calculate moles of H+. Well, I can use my new M2 value and my final volume or my total volume with the water and find moles. So now that I know moles of HCl, I can do step 3, which is the balanced equation of the reaction that's actually happening between the calcium hydroxide and the HCl. And so we can figure out how much, if I know how many moles of HCl reacted, I can figure out how many moles of calcium hydroxide reacted. We can calculate the concentration of hydroxide and using the moles from step 3 and the volume of hydroxide used in the titration. And then we can use what we know about the molarity of OH minus and the stoic ratio of calcium, right? 2 OHs for every 1 calcium, to figure out the concentration of calcium and plug those into KSP. You will find the actual KSP value from your textbook and then compare the two and talk about maybe some error that could have occurred and then a CER conclusion. All right, one more time, let's talk about how these calculations work. So we know that just sitting when it's all in solution, the calcium hydroxide is at equilibrium. So we have this saturated, once we filter it, solution. And so some of the calcium breaks off into calcium 2+, some of the hydroxides are here, some of it, well, we got rid of all the solids. So basically, we are at equilibrium. No more of this guy can possibly dissolve. So essentially, what I can do is if I can find the concentration of hydroxide at equilibrium, and find the concentration of calcium of at equilibrium, right? We find this one from the titration, and we find this one because it's related to OH. For every 2 of these, there's one of these. if I know these concentrations, I can plug in and solve for KSP. Well, how do I find the concentration of the hydroxide in this equilibrium or saturated solution? That's where the BCA table comes in. So we reacted this solution over here, we reacted it with the HCl. We found moles of HCl in like number 2 in our calculations. And we know that both of these things are going to run out because that's the definition of the endpoint. When the color changed to light pink, both of these ran out. So if I know this number here, I can solve for x, this divided by 2. And then once I have x, I can solve for question mark. Once I know the concentration of OH that we started with, I can divide that by the volume used in the titration and get molarity. Once I have molarity of this, I can find molarity of this because it's a 2-to-1. And then we can plug in. So hopefully that helps you with your calculations. Reach out if you're confused. All right, any questions? Great. Just kidding, it's a video. If you have questions, come to class with them ready to roll or email me, but we will need to be efficient. So you and your partner will need to get rolling right away. Maybe one person starts doing the filtering, the other person starts getting the HCl ready for your first round of titration, so that way you can hopefully get through 2 or 3 trials in a 50-minute class period. Have a great day, everyone.